that we're going to hear from today as they showcase their technologies are making a difference in the lives of Texans. They're making our nation stronger, and they're meeting the needs of our globe and our planet. The world really does have an insatiable appetite for energy. The Energy Information Administration predicts that energy use is going to increase by 50% by the year 2050. We have to have more and better, reliable, affordable, sustainable, attainable sources of energy if we're going to improve the human condition. And that means all of us have to have a rational conversation about our energy future and how we're going to meet those needs. Limited or rationed energy sources cripples economies, it distresses families, and it thwarts growth. The world is asking for affordable, reliable, clean energy sources, and your work remains critical in reinvent all energy sources as they come together. I'm excited to see the industry coming together. Our trade associations are coming together as well. We have the Permian Basin Control Association with us today. The Permian Road Safety Coalition is here with us today. And we even have people in from Oklahoma that control the lines. Well, thank you and your team for coming today. We appreciate it. We do have an exciting
me, and we'll award the winner the audience favor. And then Dale and David will also present the expert commentator pick for most innovative technology. So if you look at your agendas, you have some spaces to take notes so you can remember which one is your favorite. And then finally, as Tom said, we'll have a door prize that will be fabulous. It's wonderfully getting cooler, so make sure you got a ticket along with your meeting time this morning. Alright, so let's get this party started. We'd like to introduce David French with our first presenter with Streamline Solutions. When he makes his way up here, I'll tell you a little bit about the company. Streamline Solutions' mission is to provide innovative solutions for flared and stranded gas that converts a wasted natural resource into clean energy. With a focus on electricity and crypto mining, provided demineralized or purified drinking water and heat anywhere in the world with protecting the environment. David, I'll turn it over to you.
Thank you very much for having me. I appreciate it. I'm David French from Streamline Solutions. And what we're talking about today is converting stranded or flared gas into energy for the end user. Streamline Solutions, what we're doing is for the end user is for agricultural, for greenhouses, sunlight, green power for in-field operations. But because of China outline crypto mining in China, there's been a mad rush for these data boxes who consume huge amounts of electricity for cheap sources of electricity. So what we do is we convert the flared gas, which is a wasted natural resource, into power to power these crypto mining houses. What I'm going to talk about is what oil and gas is looking for, how the power is generated. What I'm going to do is I'm going to go over what the ordinary procedures are in today's market, the way that they're converting this natural gas into power. Then I'm going to introduce new technologies in the crypto mining field that is going to be introduced in the next 6 months. And really is a huge innovation in the way that they're being done. These are some of our alliance partners. Here's some of our test facilities. The picture on the far left is myself and one of our associates at the Crypto Mining Center with the Ocean Miners in Arlington, Texas. The one in the middle is a gas field in Utah, Colorado border. And then the one on the far right is what they call an immersion data center box, which is some of the latest technologies for this crypto mining is on. One thing I want to stress is you can't do it alone. There's a lot of moving parts to this. You need experts in the oil and gas industry to convert the gas to burn or clean energy with the plant gas or whatever these generators are very extremely. You also need experts in power generation, crypto mining, the batteries, logistics, crypto wallets, or what we've done. We need to assemble a team of experts in their specific industries, put together a management team that takes this process from A to Z. One of the problems or challenges that people in the crypto industry have is they really don't know how to get started, and there are so many moving parts. What they want is some association or company to come in that can take it from step A, cleaning up the gas, all the way to crypto mining and beyond. The gas requirements, I get this question a lot. The gas requirements that we're basically looking for is pretty much clean gas. We want low and no H2S. We want the methane content on the upper 70s and 80s, PSI of 60. We're not looking for gas that has 5,000 parts per million of H2S. And if somebody wants to get started, the way that we get started is we get a gas analysis flow charts and site maps for their particular location. These things are built specifically for that particular gas well and that location. It's not one size fits all. The generators that a person like the most with prime power, if the gas well has to be clean, we have a person who has to clean it all, we can filter the condensation scrubbers.
miners, 80% of your day-to-day operational costs are consumed just in electricity costs alone. That's when the flared gas comes in. This is what an immersion mining container box looks like. The picture on the far left, those are the racks that actually have these immersions in them. You can overclock these immersion miners up to 140 without any problem at all. The immersion liquid that's actually used for these, it's like a glycol mixture. The picture in the middle shows some of the plumbing that it takes to actually cool the immersion mining liquids, and the one on the right as well. All the red piping is, of course, the hot coming off the immersion miners, and blue is actually the cool. So we keep these miners at a consistent rate, which means you don't need a lot of maintenance. You reduce the downtime, and it also keeps them from overheating. And you get a lot more power, a lot more hash rate, and they can mine a lot more coins.
Again, this is what the immersion box looks like. This is the control panel. When I first saw it, these look like something out of NASA. All these miners are individually monitored and monitored from their computer and if anything goes wrong with one of the miners, you can actually shut that miner down to your computer so your whole operation doesn't get shut down. Again, miners. This is what actually looks like. That's the energy. You actually take this oil and the glycol cells that you pull the fans off, you overpower them. That's actually what the miners we have in buildings in Texas. Okay, the difference between immersion and fan cool. You get a lot more power level, a lot more results off of the immersion. These are the same exact miners. If you look at the graph, the date on top is immersion, the bottom is fan cool. Obviously, fan cool. Risk assessments. Despite price of Bitcoin, paybacks largely depend on Bitcoin and US dollars. Our break-even point on immersion miners is about $4,000 a coin. With the fan cool, it's about longevity, unforeseen gas quality issues. The gas that's coming out of the soil, if we are able to keep it consistent, well, that should be a problem. Production issues with oil and gas. Environmental regulations. Now, when we talk about environmental regulations, it's based off Bitcoin. I hope that's true. There's government regulations right now that are being implemented to try to overtax it with some other issues that we need to work on. The one on the bottom of the line, in my opinion, is the most profound.
has in the environment. So we're a proprietary camera, we have a visible RGB camera, we have an anemometer, so monitoring wind speed and direction allows us to do quantification. We have integrated communications, or we can use customers' comms. We have a 360-degree pan state, so the camera does rotate 360 degrees. And it is field rated -40 to 158 degrees. We have devices that have been 2 seasons through the hot summers and made it through the Texas snowpocalypse. So from the camera, we generate the candidate images, send them to our cloud, which is based on Microsoft Azure. Also, the camera itself, the Edge component, runs Microsoft Azure IoT Edge. So in the cloud, we're doing false alarm mitigation. We provide an assurance of 0 false positives. So what happens is when there's a set of candidate images that are verified, the customer is notified with an email. And then from the email, they can click on it, go to the portal, and see what's going on, take a look at that, print it, generate work orders, and that sort of thing. So currently, the way we're getting that data into SCADA is through CSV exports, but we do have a couple of customers that have us on the hook to publish our API by the end of Q2 of this year. So we have multiple fields of view. So I mentioned that 360-degree pan states that's inside the camera. That gives us the ability to have up to 3 fields of view that are 45 degrees each. So with one camera, and having a range of between 50 and 100 meters from the camera, that gives us the ability to generally cover a site with one camera. Sometimes, like installations where the take batteries across a pad and there's 8 or 9 compressors, it could take 2 to 3 cameras. So in the operational improvement, so this is the fun part. My background's in SCADA, process controls, and telemetry. Bless you. We'll start off with number 2. So we were watching these tanks right here because that's the big offender, right? So we're looking for gas coming out of the top of them, and we see this gas coming across the bottom. Well, what the heck's going on there? Nobody's looking for gas there. So we pan the camera over and we find that these low pressure water tanks are flowing gas. Like, they're proud of it. They're supposed to be, you know? But we got to look in to see what was going on, and they had a few things happening. One was that they had no retention time on their separation. So as soon as the separator filled up, hit the high level, it would dump. So just by changing the control system and adding a little bit of retention time, they were able to let gravity do its work. The other thing they could do is elevate the temperature or put it across a pressure drop. All of those meant facility changes. The other thing that they found by taking this data and running it, I saw somebody might be here from CCOPS. Okay. Anyway, so they took the SCADA data and our data, ran it through CCOPS, and found operationally what was going on, and they did have some other issues. And they were running a low pressure flare and a high pressure flare, and they realized that they had some constraints in their facility design and piping, and they were having a back pressure that was actually pushing gas through their water tanks. Would have never seen this, never found it. And it was interesting how many disciplines got involved in finding the solution of what the origin was. So this is another one. This was an evaluation, first one with this particular customer. And they had 11-point sensors around the asset monitoring gas, and that was going to be their kind of benchmark for moving forward for ESG. And as soon as we turn the camera on, it's, hey, that Anardo valve you got there, it's flowing a lot of gas. Your camera must be broke because none of our point sensors are saying anything. They're all sitting around 0. So you can find some articles out by some of the big majors about gas lofting, and it's kind of the phenomenon about how point sensors, gas or methane sensors going around the well pad, depending on what's happening with the wind, the gas just goes over the top of them. So our confidence level in being able to capture what's going on in the tank tops is really, really high. So this is an example of, you have something going on like this, what do you do with it? So they have a pretty sophisticated system that's in the Delaware Basin, and they're monitoring their tank pressures here with redundant draft range pressure transmitters. And they have this kind of threshold, and on that threshold, that's where the VRU is supposed to power up and start drawing the gas down. And it wasn't happening for a couple of reasons. But these timestamped events that we had here, by importing this data in and having a correlation between our events and their process control, they could find some things from a data perspective that were causing these events that they weren't even looking for. So this one's kind of unique. So I mentioned that our camera sets up 30 or 40 feet and it looks down, right? So we can't look into the sky and resolve anything. We don't use a thermal detector. We use a spectroscopic absorption detector. So this was a site that we had not been monitoring the flare, and a guy was just kind of playing around with it and panned over and saw this was going on. And we contacted the customer and said, hey, this you got a flare, it's lost ignition. He looks at his SCADA system and says, no, I'm showing about 1200 degrees on my flare right now, and it's updated every 5 or 10 seconds. So it was getting late in the day, and it was about a 3-hour drive to the site, so he said, how about we just wait and look at this tomorrow? So we did, and it still looked just like this. So he makes a drive out to the site, and the flare had blown out, and the 1200 degrees that he was reading was accurate, the pilot was lit, but the flare had lost ignition. So because we just started monitoring, we don't know if the flare had just blown out when we saw it, or if it's been out for 3 days. So we do some pretty cool flare monitoring. So what you're seeing here is the sun is shining across, the flare didn't fall down, it's standing up. And as the sun is shining across, the methane in C1 through C6 plus is blocking the spectrum of light. So it's missing in the shadow here, and we're colorizing that absence of light. So I think this is my last one. So I drew this one, so it's not quite as dynamic, but tells a good story. We had some guys that were reviewing the images, because we review the images and we're always improving the math that goes on behind it. And we have some really great models of what plumes of gas look like in different wind conditions. This one didn't look like anything else, so they thought maybe it was a false, some kind of a reflection that we've not seen before, and not built a model around it. So we sent a guy out there, and what was happening is that line from the tank tops to the VRT, you see there's very little, if almost no slope in it. It was holding liquids. So when the VRU would run its cycle and stop, the liquids would settle right there, and they're super corrosive. And they had eaten pinholes in that lateral going to the VRT, and it looked like the bottom of your barbecue gas grill. So what would happen is they'd run a cycle, and then when the vapor pressure starts building up, they would start flowing gas out of their gas grill, basically, producing gas out of that lateral. Then the VRU would come on. Then they have another problem, because now they're drawing the gas off the tank tops, but they're also drawing air in. So air puts them at risk with the midstream company of getting shut in if their O2 level's too high. So they had a couple of things going on, and they were in the process of, they'd only had a couple of these cameras deployed, but they went out with their handheld to do an inspection and ended up with a pretty significant repiping exercise, because this was going on at a whole bunch of their sites. And this is kind of a new one. This is a truck loading terminal. What's going on? When you can see the operator on the left, that's the OGI camera. And then on the right, you can see that there's a fair bit of emissions that are going around during that loading process. You'll also notice up here that this compressor, that compressor's got a whole bunch of stuff going on as well. So from an ESG leadership perspective, there's, I don't know, are y'all familiar with METEC? It's a methane environmental test thing. It's a lab that's been put together with Colorado State University. And they have a program called AIDED. Actually, I probably wouldn't have to think about this, it's up here. So, Advancing Development of Emission Detection. So I mentioned that 10 kilograms an hour. So that's kind of what's proposed right now by the EPA to be, if you're going to do continuous monitoring, that's going to be the lower threshold. And what they're looking for is, what is your 90% probability of detection sensitivity? How small of a leak can you get 90% probability of detection? And we were at the METEC aided program, put us at 3.7 kilograms. So that's far below what's required by the EPA. Having the lower number is good here, it's like golf. So 90% probability at 3.7 kilograms an hour, and 50% at 2.2. Also worthy of mention, we had no false positives. By the way, this task is hundreds of blind continuous samples, releases that they're flowing on different pieces of equipment around their 11-acre well site, basically. And then they're looking for what's your probability of detection, what's your rate of false positives, and what's your pinpoint accuracy. So the pinpoint accuracy means that you're able to determine which specific piece of equipment the gas was leaking from. And not just that it was leaking, it came from by the tanks, or it came from by the separators. Which piece of equipment was leaking so that it can be addressed. And through 5 months and hundreds of samples, we had 100% pinpoint accuracy. So in comparison, this is, I know we can't talk price, but this is one that's multiples different. And its probability of detection, and it's based on a thermal technology, and its probability of detection was 5.6, and at 50% was roughly 3.5 kilograms an hour, and was about 50% accuracy. So more than twice the performance. And then this is point sensors, which are pretty common, and we actually have discussion going with a number of point sensor companies for kind of a hybrid solution. And point sensors basically, this is the chart that's generated from the METEC program, and I contacted Clay Bell, the PhD that does this report, and asked him, what's this mean? And he said, well, basically, they can never achieve 90% probability of detection, and because they're running across all these different flow regimes, you have basically the same chance of missing it as you do seeing it. So from that perspective, we performed really well. So just kind of a recap on the technology. So we work similar to an open path detector like you would find in a chemical plant, and we're looking for the light spectrum that's missing between us and a reflective source. We don't get confused by vapors or anything like that. That's a characteristic of thermal technologies. So some common things are trucks, compressor exhaust, wildlife exhaust. So those can set off false alarms on thermal type devices. We're not subject to that. So we do the processing in the camera. So methane and C1 through C6 plus. We take an image about every minute. We use the wind speed and direction. That helps us with our quantification models. And then that's kind of it. So, check us out. You should be able to scan those QR codes if you'd like. We have a brochure and also my contact information from that. But our real difference is our cost to performance ratio of what we're doing, the no false positives. When we got started into this and going commercial a little over a year ago, it was, okay, you guys are using these different kind of technologies. What's your biggest problem with them? And they said, we chase ghosts. We have so many false positives. You got to eliminate that. So we made that a priority for us. Anyway, with that, I'll wrap it up and take any questions.
Awesome. Thank you so much, Robert. We're out of time for questions right now, but during our networking break and before lunch, we'll have 2 networking breaks. We encourage you to talk to all of our presenters with any of the questions that you might have. So thank you, Robert. Appreciate it. All right. Now don't keep that. Now we'll move on to, we'll hear with John Rogers with Locus NGON Solutions. And while he makes his way to the stage, they turn carbon-neutral biosurfactants into performance-enhancing treatments tailored for upstream and midstream oil and gas applications. So I'll let you take it from here.
Thank you very much. Can you bring the slides up?
Perfect. Thank you very much to TXOGA for this opportunity this morning to come in and talk about new technologies. Hopefully I'm going to show you a technology now that is both novel but proven. And I think can tie together some of the biggest themes that we have at the moment, which is domestic oil and gas security, but also doing it in an environmentally friendly way. A lot of aspects that we think we can positively affect the oil and gas. One is a big reduction in Scope 1 emissions, and also getting more of existing wells, so less wells going P&A, and so that we can extend the life and don't have so many wells leaking after abandonment. So obviously, the world has changed in the last few months because of Russia. I think there was obviously an ESG trend that was coming through, but that's sort of gone on the back burner, but not away, as the world says we need energy security. As you're probably aware, if Europe does go ahead and put the ban on Russian oil, JP Morgan say the oil price could top $100 million plus. So it's obviously a big issue, but the ESG genie is out the bottle, and we're not going back to anything that is not clean. I think the US can and should make the cleanest hydrocarbon in the world. So I'm going to talk about a solution today, which is biosurfactants. Now, surfactants are a well-known industry. It's about a $4 billion a year market. I'm sure that surfactants, people are going to say, well, what's new about surfactants? Well, hopefully we can show you something. As Todd mentioned before, there's no scenario going forward that does not require more oil and gas produced by the US. So what do we do typically previously even when we wanted to get more oil and gas? We fracked. But as you're all aware in this room, obviously fracking to go from today to bring a new well is probably about 8 months. And you need flat fleet, you need steel. The cost of diesel has gone up by 44% since January. So there's a lot of problems with that. Plus, people are concerned about an upcoming recession. So are we really going to be investing in frac fleets, putting in demand that could go away? So this is why I think that if we look at fracking, it will always be the mainstay of what we do for production. But can we do something else? Is another toolkit that we can use? So one of the big things also about fracking is the amount of water that's used. And seismicity issues are a big issue here in Texas as well. So what our chemistry does, and I'll explain and I'll back it up with some case histories, is we can actually go in either at the frac stage and basically liberate more oil than you normally would, or we can go in almost uniquely halfway through the life of the well and actually give it a boost. And what we can do, the most efficient way that we do it, and I'll show you later on some of the results we get, is a refrac. So we can actually go in and refrac the well when we're putting in a new completion. By putting in a pill of our chemistry, we can actually bump the production up for about 40–50%, and it's sustained for about 12 months. Greenhouse gases we mentioned here. One of the things that I think is also going to be on the agenda is getting more of existing wells. You're probably aware there's 3.2 million abandoned oil and gas wells in the US. About 1/3 of them were actually cemented off, the other 2/3 were not, and they're the ones leaking methane. So I think getting more of existing assets. At the moment, we only get about 10% of the original oil in place now. I'm going to show you now some techniques that we think we can get from our calculations 40–50% oil and gas. I also mentioned about the carbon footprint. So this is industry data about how much diesel is used for a typical 50-stage frac. And this is not all the thousands of trucks needed to take sand in, etc. So the carbon footprint of a frac, you can see here, is about 1,000 tons of CO2. It's equivalent of the amount of CO2 that's produced by 210 cars plus a year. Or you'd have to put in hundreds of acres. What I'm going to show you is this is a one-stop, very low carbon application that we do for a well that's maybe halfway through its life, and you basically need one pumper truck to do it. Also, the water is not required like a frac or a refrac. We just use water as a carrier for the chemical pill we put in. Okay, so what's different? So A lot of the oil that's not actually flowing from a given well is actually trapped in some of these extremely tight pores that we have in shale. Now, if you remember your chemistry lesson, we did capillary pressure, we'd have those little glass tubes, and the smaller the diameter of the tube, the further up the tube the liquid went, and that's basically capillary pressure. So that's the attraction of the liquid to the surface. So the smaller you get, the higher that capillary pressure gets. If you look at something like we're showing here, which is shale, Wolfcamp shale, some of the smaller ends of the frac are down at the nanometer level. Now, if a surfactant can actually get to this oil, we can change the wettability of the surface, reduce the interfacial tension, and mobilize it. But if you look at the sort of industry standard surfactant, which is represented by that dumbbell there, that so-called micelle is the lowest energy state the molecules will orientate themselves in a solution. Over the last couple of years, there's been some progression to try and get that down to a smaller size, and things like critical nanofluids and microemulsions came up. That's what we're looking at in the middle. Now, the biosurfactants that we use, it's nothing that we've done. These will naturally have a micelle size, which is about 3 nanometers. That's about the size or the width of a human DNA. So we can actually penetrate further into the cracks and microcracks, change that wettability, and liberate more of the oil. Now, the other unique aspect of these products, unlike a normal surfactant, is they're actually retained on the rock and have a very slow desorption, and their so-called their so-called minimum effective concentration is single digits. So all the data I'm going to show you now is going to be that in action. So this is a well that we fracked. I'm looking here at Texas RRC data that we picked up on Drilling Info. This is a well that we fracked in the Wolfcamp. We did it Q1 last year, and we were a third of the dosage rate of the incumbent premium frac surfactant in there. So again, this is 12 months data. It's not our data, it's public domain data, and you can see that over that 12 months, we actually changed the decline curve. We were liberating more oil from this action I was telling you about, better penetration, retention, and changing their wettability and interfacial tension. And the same with the gas as well. We have over 300 case histories now, a combination of fracs, refracs, and going into wells halfway through their life. So we believe that this is a valuable addition that operators can do rapidly. We're not asking anybody to change their operations, we're asking them to augment it, or we're asking them to swap out the surfactant that they use every day and get a benefit like this on the frac. This is a case history from Delaware Basin. This is a well, and you can see with the green line started off at about 1,000 barrels a day, and over about 2 years declined down to about 20. And we put in 1 pill of our chemistry, and this is data after 155 days. It actually continued above the predicted decline rate for over a year. You can see it's both oil and gas incrementally. Now, interestingly, that 4,500 barrels of oil that we produced in that 155-day period, we can call it low carbon barrels. Those incremental barrels, if you put the carbon footprint on those based on how much energy we use, scope 1, to produce it, it was about 1/10 of the carbon dioxide loading that we had per barrel on the original frac barrels you get. Application is key for this technology. If we just pump it in as a bullhead, then a lot of the factors is, did the chemical actually get to a place that can do some useful work? So a lot of people want to do bullhead, but it's not the most efficient. You don't really know where the chemical's gone. Up in the back end, we actually had one well we pumped in, and the lateral was blocked. And we know the chemical diverted to a well next door. That well doubled in production, again, looking at the drilling data. But this is one again in the Low Spraberry. And again, looking at this is 3,000 barrels of extra production, and this was maintained for at least 6 months. We use this product with acid. This product can be used up to 15% acid. You can use it from pH 2 to pH 11. It's stable, it doesn't degrade. It's not a fragile chemical. You can use it at up to 300 degrees F. But this is where they use it as an acid stimulant. And just put it as a spearhead, you can see here that we got large increases. Now, if I'm sitting up in the audience here, I'm going to say, okay, you've cherry-picked the data here and just shown us the best ones, but we would love to speak to you after this and actually show you the 300 case issues that we've got. Now, the ideal way of putting our product in, which 95 to 96% of the time, is when you use something like an isolation tool. So we work with a partner company called Commit, and they have like basically an inflatable packer on a tool. They can go right into the toe, bring it back, and we know that we're putting the chemical into every area that we want. And you can see here again the bump in the production that we've got, both on oil and gas throughout here. So, what we'd like to say is the technology available today, it's low capex. You don't have to change what you do at the moment. Same frac, same refrac, or go in with a stimulation, and we think we can make a significant increase in the amount of production we've got. Now normally, right on the conference, we start off with the fact that, oh, by the way, we're also green, it's 100% renewable, it's made from canola oil and sugar. But again, I've been 34 years in the business, and green used to mean not quite good enough, or didn't quite work well, or it was fragile. So we wanted to push here on the performance first. But by the way, it's manufactured in a carbon neutral plant up in Cleveland. It reduces scope 1 emissions, and it's got about 1/10 for the aquatic toxicity of a typical surfactant. So thank you very much for your time today. I would love it if you were to scan my QR code and come and see Tom and myself for any questions.
Awesome, thank you so much. We're running a little bit behind, so we'll take questions, sorry y'all. Thank you so much, we appreciate it. Again, we'll have a networking break, so that's a good time to ask questions then. Okay, next we have Matt Tunney with NGON Solutions. So we'll have him make his way up to the stage. And they're a green energy service company that works with oil producers to reduce emissions in an environmentally responsible way. And their service captures otherwise wasted flare gas at the wellhead. So we look forward to hearing more. And I'm sorry, it's Jay. Jay is presenting, so thanks so much.
Thank you all. Ladies and gentlemen, appreciate you being here, and thank you very much to TXOGA for the opportunity to present to you today. As I'm not Matt Tunney, I am Jay Bernard. I'm the head of ESG investment at NGON Solutions, and I'd like to take the opportunity to share information about our company, why we're in this business, our goal of becoming partners with oil producers to address the growing industry regulations and environmental concerns. Today I'm going to discuss the following: who we are and what we do, what the problems are facing producers today, how our company intends to solve these problems, and to provide real examples of our deployments. NGON stands for Natural Gas On-Site Neutralization. We are an energy services company that helps oil producers reduce their methane and CO2 emissions by capturing flare gas. Our team is comprised of professionals with a proven track record of success in multiple facets of the oil and gas, crypto, and power generation industries. This aligns us to execute our goals of improving operational efficiency across the oil and gas sector, of achieving better community and regulatory relationships, and supporting and sustaining ESG strategies and programs. The main issues facing the industry today are as follows. Natural resource waste, as burning natural gas into the atmosphere is not only an environmental issue, but a waste of valuable fuel for energy production. Additionally, flares are very inefficient, so they release methane directly into the atmosphere by venting, which is much more harmful than CO2 alone. Takeaway capacity is often expensive and impractical, leaving no way to monetize the natural resource, particularly on new drilling operations. Access to public funding. Our process helps improve ESG scores for oil producers, which has become a much greater focus of both private equity and public credit markets in recent years. The main problem that NGON addresses for producers is the reduction of this harmful flaring. So let's talk about why oil companies, such as yourselves, need to look at this problem much more seriously right now. Both net carbon footprint and methane reduction have become much more of a regulatory focus in recent years after COP26 and the recent discussions in the last week around Build Back Better. More regulations are focusing on emission reduction across the spectrum at the global, federal, and state levels. Increasing regulations do directly affect the oil and gas industry, and as sadly as we want to say it, as profitable companies, you are going to become targets from regulators, especially with increased pricing. Via COP26, the U.S. has committed to cut methane emissions by 30% by 2030. And right here in Texas, regulation is ever-changing, as we know, and 19 new bills have been introduced regarding flaring in the past year alone. Some states that we operate in, or that we're looking to operate in, have banned routine flaring altogether, and it is very likely that other states will follow suit. It's very clear that oil producers are under pressure from many angles to act on this issue. So what we do as an energy services company is to work with oil producers in a symbiotic arrangement that brings together two burgeoning industries, oil and blockchain, for the benefit of both. Our solution brings consumer load directly onto the physical site, which stops the waste by eliminating the flaring and reducing the methane and CO2 equivalent emissions. So how do we do that? It's very simply, we capture the gas before it is flared with hard piping, and we divert it into generators. We use these generators to power on-site data centers. These data centers are modular and mobile, so there are no grid connections off-site, and there's no expensive connectivity. This is a fully remote solution. We run servers in the data center which produce revenue while consuming power. For our operations, that is typically Bitcoin mining. We are currently operating this model on 12 sites across the U.S. that range from 50 to 1,200 MCF a day. We have engineers and field operators that go on site for design, installation, maintenance, and routine checks. Here's an aerial view of one of the sites we operate on. On the left, you can see the processing and oil storage equipment, and on the right, at a safe distance, you can see the NGON containers and generators. The piping underground feeds into our generators, and then the modular data centers in the containers consume the electrical power. This site was deployed last month, and is currently processing around 1,100 MCF a day. Here's a close-up shot of what our on-site operations look like with the generators powering these mobile data centers. We designed a custom solution based on the location, the layout, and the volume that we are producing. This was one of our first and smallest sites. We are on the right-hand side, and you can see the fans running in the data center. I didn't pick the music. From a logistical standpoint, we have experienced oil and gas attorneys drafting our production handling agreements. There is minimal installation time, and we are in full compliance with all safety regulations. There's no disruption to existing operations, and no downtime needed for implementation. There's also minimal on-site maintenance once up and running. We have an excellent health and safety record, and we also take care of all the air permits that are needed to operate on site. With a few competitors in the industry, what distinguishes NGON from the rest is our team, which I'm very proud to be a part of. We have excellent relationships with vendors and suppliers across multiple years of experience in the logistics and supply chain field. And each member of our management team has over 20 years of experience in the oil and gas and asset management industries. So we have a very thorough understanding of the industry and its challenges. We work directly with oil producers to help them operate and solve their problems. We are a services company. I want to very much reiterate that. And our top priority is the client relationship. Here's a time-lapse image of one of our sites as we turned on our equipment and consumed the flare gas production and reservoir. This is my favorite part. So in sum, NGON is a green energy services company that works with oil producers to reduce their emissions in an environmentally responsible way. We view our technology as one that can provide significant value to the E&P space immediately, and we are actively seeking partners to do so. Present today with me are Jay Wayne Ballou, our Chief Commercial Officer, Jamie Alford, our Director of Business Development, and Ben Young, our Public Relations Director and lobbyist on our behalf in Washington. Please reach out to them and bother them today. I thank you very much for your attention. I'd be happy to field any questions if we have time. I know we're running up on.
Yeah, I think we have time for one quick question.
Can you talk a little bit about the revenue model in terms of like what is the client engagement like and what are they actually buying?
Sure. Clients in many circumstances can buy one of three options. They can effectively, some of the wells are really in danger of being shut in, and those wells, in some cases, we can pay for the gas. In some cases, we have an agreement where you pay a small nominal fee for the gas in order to actually take away it. And in the third arrangement, the producer has the option to participate in the process and the revenue stream generated.
Awesome. Thank you so much, Jay. We appreciate it. Okay, now we'll take a quick networking break, and so you can talk to all of our presenters. We also have some awesome booths outside, and then we will be back here. Let's see, we're running a little bit behind today. Let's be back here at 10:25, okay? Thank you. today on Twitter. And I know we had, I think TCQ Commissioner Bobby Janica is here. He might be outside still, but welcome. Thanks for coming today. Let me also make sure Heather is in here. Oh, she's in the back. Okay, great. All right. Okay, well, we'll get back on track. So next we have Heather Smersina with Onboard Dynamics. And the goal of Onboard Dynamics is to support the natural gas ecosystem and reducing global greenhouse emissions safely and reliably through their innovative and practical commercial solutions. So we welcome Heather to the stage. Let's give her a round of applause.
I'm Heather Smersina, and I'm the Director of Business Development for Onboard Dynamics. I want to thank TXOGA for inviting me to present at this technology showcase. It's great to be here. I'm going to give a little bit of a background on our company and then talk about our technology innovations that are helping to reduce methane emissions during pipeline evacuations. Okay, so Onboard Dynamics has been around since 2014. We spun out of technology that was developed at Oregon State University, natural gas compression technology. And at that time, we were funded by the DOE Advanced Research Project Agency for Energy to address a critical lack of infrastructure in natural gas refueling. So that's how we got started. We developed our technology. We did commercialize 2 products for that space, so we are in the market now fulfilling those needs. They're still out there today, and you can see those in the middle. But what I really am here to talk about is really a result of listening to the voice of our customer and then being in the right place at the right time with the right solution. And that's what led us to the Go Back Flex. So we had a customer, one of our major natural gas utility customers, that wanted to use our compression system to do pipeline evacuations. So we demonstrated that, and after that successful execution of that project, that led us to develop and launch the Go Back Flex specifically to address those types of applications. So before I get into the GoVac technology further, I wanted to show this picture here. These are our first 2 products, so that's the GoFlow and GoFill, and you can see them out there at this remote site. So those 2 units together provide a complete natural gas refueling solution that's mobile and runs on natural gas without requiring any electricity or any other fuel source. So what you see here, this picture is taken in Western Oregon, and the company was evaluating a Hyliion Class 8 CNG EV hybrid truck as part of the Northwest Natural Truck Loan Program. So they were challenged with this site out of this quarry, and they didn't have any access to public refueling out there, and they didn't have robust electrical service. So we brought the GoFlow and GoFill in there in the morning, and we were refueling the truck by early afternoon. Okay, so now on to pipeline evacuation and our solution. First, I wanted to say that I wouldn't be here if I didn't strongly believe that natural gas needs to play a critical part in the evolving net zero energy system. So we need to reframe the way we look at natural gas and the way we talk about the gas ecosystem. We need to really focus on the many advantages of natural gas and address the risks that are associated. Just like electricity can be carbon intensive or carbon neutral based on how it's produced and used, the same applies for natural gas. So even though natural gas is having a bit of a moment now on the world stage, I think everyone in this room probably acknowledges that stronger regulations are coming. So we saw the Pipes Act signed into law at the end of 2020. It created dozens of regulatory mandates and requirements to report on technologies and practices to prevent and minimize the release of gas during planned repair, replacement, and maintenance operations. Then a year ago, we saw a bill introduced into Congress to levy fees on methane emissions. And then more recently, we saw FERC voting to expand their influence and oversight of the industry. But the good news in all of this is that there are now solutions that are commercialized and available to eliminate intentional methane releases. So what's being done today when it comes to pipeline evacuation? We know that depending on the particular operator and the location and internal and external pressures, a number of different possibilities are being considered. So the gas can be flared, or it can be vented. It can be flared like you see in this picture, or the gas can be drawn down and then vented and flared, or it can be purged, or it can be compressed. And that compression can include cross compression, where the gas is captured and transferred into an adjoining pipeline, or it can be compressed up to high pressure to 3,600 psi and moved into a tube trailer. So the challenges that pipeline operators are facing today in addressing these options and selecting their methods, many challenges. First of all, public scrutiny, especially in urban areas. So this is an issue. Stakeholder pressure from the corporate level. Also, time to perform the projects. So time is always of the essence, as you all know, on these projects. There are usually many different permits and different contractors all trying to get their work done on this job in a certain time frame. So the time is critical. And there's been a lack of solutions, lack of equipment availability, and then also a lack of the appropriate equipment scaled specifically to the many various types and sizes of jobs that are out there. And then finally, validation and accountability. So how are the companies going to validate the emissions that they're reducing and then report on it? And that's going to be required. So in order to support operators in doing the right thing and reducing the emissions, a number of considerations about the equipment itself. So it's got to be easy to operate. It has to be easy to set up and deploy. It must be safe and compliant, fully automated, and then fast and efficient from beginning to end of the project. So those are all really key to encourage adoption of the technologies. So we believe features to look for when you're evaluating equipment include a number of things. So first and foremost is a source of power. So is the equipment running on, does it require diesel to power an air compressor or a generator? Does it require electricity? Or is it running on the natural gas out of the line? Big consideration. And then the small footprint. So the flexibility to maneuver on job sites and not have multiple pieces of equipment is really critical. This picture sort of highlights that. It's a very challenging site on the slope of a hill, and there was not room for any other equipment. And really a small piece of equipment was required. So flow rates and capacity are also key, of course, to selecting the right solution. And then system monitoring, having the ability to capture the real data and to provide reporting. Very, very critical for a good solution. So now today, there are a handful of technologies across the performance spectrum that are out there and available for operators to use with pipeline evacuations. We launched one of them just last year. This is the GoVac Flex. So the GoVac Flex provides a solution that really is truly near zero emissions on your project. So the system runs, it draws down the pipeline to near zero or whatever pressure you want to stop at. It uses only the natural gas in the pipeline as its source of power. So then the recovered gas, you have options with the Flex. It can either be transferred into the adjoining pipeline, or it can be compressed up to 3,600 psi and put into a tube trailer to transport and re-inject into the line elsewhere. or to put into a storage vessel and use that CNG to fuel vehicles. I did want to mention a couple parameters about our system. So our flow rate is 100 SCFM, so it's about 140 MCF per day. So that's our performance. We also can accept pressures. We're flexible on the inlet to accept up to 1200 PSI. And then on the outlet, we'll compress to whatever you need to do up to 3600 PSI. So it's a differentiating factor. So our system is completely automated. We've got many sensors, electronic valves. We have flow meters on both the inlet and the outlet, so we can tell exactly how much gas is being captured and recovered. And this is really a critical differentiator to other systems that are out there. And we provide these reports. This is an example after the fact that this example was about 3.5 miles of 12-inch that was evacuated starting at 390 PSI. And it took 21 hours and 40 minutes. And we evacuated almost 100,000 SCF of gas in that time. So another thing that's unique about our system, you'll see down at the bottom, we're taking into consideration the emissions associated with actually running the engine. So that gets deducted out before we give the total impact of the job. So in this case, it was about a little bit less than 7% of the gas coming out of the incoming stream. So it's a very efficient system. Okay, so just a few more details about our system. So it is based on a V8 industrial engine. One side of the engine is used for combustion to power the system, and the other side is used for the compression. This really is our key differentiator and really our value proposition, because it allows us to provide the clean environmental profile, because all we're using is the gas that's coming out of the pipeline. So the system's self-contained completely. No other equipment is required. It's small and portable, user-friendly, and it's just very easy to deploy and redeploy over and over again. It's very simple to use. And also, importantly, it's safe to operate and regulatory compliant. So we're a small team of 20 people right now, but our recent transaction with BP Energy Partners has allowed us to capitalize for high growth. So we offer direct sale to utilities. We also offer leasing of equipment, and we're positioning ourselves to provide evacuation as a service. So we're very flexible to meet, any business model that our customer base has. So we're already working with a number of you, and we really look forward to continuing those discussions and moving projects forward. And also, we are continuing to innovate, so we have a product roadmap, and we're continuing to develop the technology. We aren't standing still with this first solution that we've got on the market. So that's
Thank you so much. Other, Dale or David, do you have any questions?
Yeah, Heather, I'm thinking through your competition and kind of the differentiator. And so as you think about the three different business models, can you talk about competition in the direct sales? I think that'd be much larger companies, and then the leasing options, and then the evacuation as a service.
Sure. So if I understand the point of your question, the sales are mainly going to be to the utilities and to larger utilities. Many of them want to put this into their rate base, and that's the reason for wanting to purchase. So it helps them with that business model. For leasing, we work with a number of third-party service providers. So there are companies, as I'm sure you know, that go out and do this as a service at scale. So we will work with them, lease them the equipment. They've got the advantages of having our company provide all the maintenance on the leased units. They don't have to worry about that. And then for as a service, we can do, I didn't mention this, but we can use multiple units on one job. So if you have a big transmission job and it would take too long with one unit, you can gang them together. So if you put 2 units on, your evacuation time cuts in half. So a customer may want to own one for most of their projects and their regular use, and then they might want to bring us in as a service to do that, to handle that extra capacity. And then also as companies are transitioning, as you know, a lot of companies are trying to figure out how they're going to handle this. And so doing it as a service gives some flexibility there as well. And smaller utilities.
Awesome. Thank you so much, Heather. Let's give Heather a round of applause. And next we'll have Ken White, and he's with Protonic Tech. And Protonic's innovative new patent-pending water exclusion technology and device eliminates water from the oil and natural gas production at the well level. So Ken, we'll hand it over to you.
Thank you. My name is Ken White, and I'm a co-founder of Protonic Tech. We're based in Houston. Joined with me today is my other co-founder, Joe Tran, and we have one of our key technology advisors with our company, Dr. DJ Banerjee, who's a professor of petroleum engineering and mechanical engineering at Texas A&M. This morning, we're going to thank you for the opportunity to speak to you today. We're going to talk about some breakthrough technology in the oil and gas industry that deals with eliminating produced water. Produced water is one of the big issues right now, right? See a couple of you shaking your heads. Well, we've got some answers for that. First of all, just imagine a world that we're living in. What if produced water were never produced? Well, wouldn't that be a great thing, you know? And no, folks, this isn't an electric fork where we don't need it. We need something better than what we've had. We've been in business a long, long time, and it's not working. It needs to work better. We believe it's time for clean oil and gas 2.0. It's time to eliminate the produced water while maintaining production levels and even increasing those production levels. So what's the current problem? Well, this is an obvious one. For every 1 barrel of oil that's produced, there are 10 barrels of water that's produced. And that's the problem right there, the water production. So the more water that we produce, the more oil that we produce, the more water we produce. Now we've got a problem in the Permian, as many of you know, that we're generating about 9 million to 15 million barrels of water per day. So what does this problem mean for everybody? Well, we've got operational costs. We've got transportation costs. It costs about $2.50 a barrel to transport this stuff by trucks. We can do it by pipeline. We've got cleaning costs. We've got disposal costs. We've got the ESG concerns that we're all aware of. That also is disposal. Earthquakes. Well, that's something new we haven't talked about in a while. And we've got regulatory restrictions. Many of you out here today are involved in the regulatory restrictions, and we need that. We need that for our environment because, unfortunately, I've been in the oil and gas industry. I've got many friends in it, but you know what? We haven't been good to the earth, and we haven't been good to the environment we're living in, and we need those regulatory restrictions. But it's a problem because it's causing delays in what we need. We need oil and gas, so it's a real catch-22. Yeah, Texas earthquakes. This is an interesting thing. Graphs have shown over the last 5 years that earthquakes have actually increased in number as well as intensity and magnitude. And they say that they're going to continue to increase, just like the oil, the water produced in the Permian at 15 million barrels a day. They're projecting in the next 4 years will be 30 million barrels a day. These earthquakes will continue as well. What's causing them? Injection wells are causing earthquakes. And so now we've got regulators around the U.S. as well as the Texas Railroad Commission, which I'm very favorable of, got friends there. They're limiting or even shutting down wells because of this. And what's that doing? Well, now we've got Additional transportation costs. We've got bad press. Nobody wants bad press. Oil and gas industry is getting enough bad press. We don't need any more. And the whole process is not ESG friendly, which is a lot of what this conference is all about. So what is the solution? Well, the easiest way to eliminate produced water is to not produce it. So you're all sitting out there, you're experienced executives and professionals. You say, well, that sounds pretty naive, Ken. Don't you think we would have done that by now if it were that simple? Well, I agree with you. We think that the solution to this is Protonic Tech's new patent-pending technology. It's called the water exclusion device. This device actually blocks the water, the reservoir, from coming up. So the produced water doesn't come to the surface. There is no more produced water. There's no need to truck or pipe the water. There are no injection wells causing earthquakes. There's no power that's needed. And in fact, we're going to demonstrate that it actually does increase oil and gas production. It's installed at the end of the tubing below the isolation packer. It requires no power source, and the device is actually stackable. So depending on the types of wells and the well configurations and the pressure and the depth and the flow rate, we could actually stack these devices to accomplish what they need to do. The applications are in hydraulic fracturing wells, horizontal wells, vertical wells, oil and gas wells. So we took this device out to the field. We drove out to Louisiana, and we tested it on a small well out there. You know, the interesting thing is a lot of folks say, well, we don't know what this darn device is going to do, and we'd love to stick it on our well, but what's it going to do? Is it going to blow up the well? Is it going to affect the formation under there? We got a lot of questions. So we went out to the field, and this field was producing 100 barrels a day. 99% of that was water, so 1 barrel of oil. Before the slide on the left is before we put the patent-pending water exclusion device. The slide on the right is after we put the device on there. 100% oil cut. No water. So the sample on the left is the sample from before the device was installed. The one on the right is after the device is installed. That sample is sitting right out there as a table with Joe Tran. If any of you are interested in looking at it, the sample's 3 years old, and you can see that there has been no separation in the last 3 years. It is what it is. Bob, the superintendent out in the field, has been operating that field for over 48 years. And when he saw what was happening, he said, wow, he said, I've never seen anything like this in my life. He said, this will change everything that we know in oil and gas production. So, over the years, we've developed a concept, a theory. We've hired a top-notch patent attorney firms as well as other contract firms. The device is in patent pending mode. We've got actually the device with us. We brought it today, not here, but we do have it. If any of you after the conference would like to see it, we'd be happy to show it to you. And we are currently at the stage of where we're going to be lab testing this for fluid flow and pressure rates. And Dr. Banerjee and his team will be witnessing these tests and documenting it and for publication. From this testing, we will then take the device out to oil and gas producing wells, and the lab testing will enable us to determine what are the best wells to actually really show how this thing is working in a fully operational, high-producing oil and gas well. And so there's no guesswork involved anymore. And from that, we're going to strategically align ourselves with manufacturers, assemblers, distributors, and marketers to get this thing out to market. So, we've talked about what is the single most important problem right now facing our industry from a production standpoint: produced water. So, if we can eliminate that produced water, then we can solve a lot of problems going forward. Our new patent pending device will do it cheaper, because it costs a whole lot to manufacture it. We can do it cleaner, safer, and better. Thank you for your time.
Awesome. All right, Bill, David, do you have any questions?
Yeah, thank you, Ken. You mentioned the really good field results in Louisiana 3 years ago, and it sounds like you've been working on IP strategy and a few different things. Have there been other trials, or do you have others upcoming?
Yeah, we have other trials upcoming, but what the folks want to see the lab tests first. We have a lot of folks that want to try it, and for all of you that have had the task of being with a startup company, when you start talking to folks, everybody says, "Sure, I'll put it on my well, and I'll take 75% of your company while I do it." So what we want to be able to do is take the data from the lab testing and show folks, and we've got folks that are already lined up. You prove us, you show us what this thing will do, we'll put it on our well, by God. And then they're ready for being early adopters. You're early adopters, you get favored nations on pricing and in usability. Good question, thank you.
Awesome. Thank you so much. Appreciate it. All right, next we will hear from Momus Clattery, and he's with Remote Gauge. And Remote Gauge is an all-inclusive service that monitors well productions, oil sales, and wastewater disposal with zero capital costs and minimal operating expenses. So I'll turn it over to you.
Good morning. My name's Momus. Thank you for being here today to give me the opportunity to tell you about Remote Gauge. I'll put this over here so it doesn't make so much noise. Oh, that was a tough technology to follow. That's very exciting. I want to tell you about Remote Gauge, and I'd like to start with the business model. We remotely measure what's in oil field storage tank, oil field production tanks. But there are lots of other devices out there that do that. We're going to loosely call it SCADA, Supervisory Control and Data Acquisition. We set out about 10 years ago, we're a new startup that's 10 years old, and to be the unscaled. We wanted to completely eliminate the capital expense of all the equipment on the well site. This particular well is one of my favorites. We were testing our device and learning how to deal with condensate. And we actually replaced a couple of tanks with SCADA with our devices and caught an internal theft ring, which I can tell you about more detail outside if you like. Our target market is every tank that's still measured with one of these. Most of you know or have used one of these high-tech devices to measure oil field production. I'll demonstrate it for you. A dipstick. What we've come up with is an electronic version of that. There are 3.5 million oil field storage tanks that are were measured this morning and will be measured again tomorrow morning with that device. By the pumpers, by the gaugers, by the haulers, by the other contractors. We're here to encourage you to stop doing that. Why do we do it? Because the information is so crucial. It's the way daily well production is tracked. It's the way oil is transacted from the producer to the buyer or the hauler. That truckload of oil that's leaving that tank going onto that truck is transacted based on a handwritten ticket that the driver leaves And the data he puts on that ticket came from that hand gauge. Same thing with the expense of saltwater disposal, what Kim was talking about. That ticket too is left with a handwritten result of the hand gauge. And every saltwater ticket I've ever seen said 130 barrels. I don't know what's magic about the 130 barrels onto a saltwater truck, except that happens to be the weight limit on the roadways for salt water. So did that truck really take 93 barrels or 106 or precisely 130? That's something that remote gauge can be quite accurate about. Here's the horror movie for the day. This is nothing that we want to see in the oil field. But the way to prevent a spill is to measure the tank width today. And the pumper has a general concept of his production rate, so he can predict things like this, but obviously not all the time. Hand gauging is also expensive in windshield time for the employee. One of the big dangers, we'll talk about in just a second, is climbing the tanks. It's also expensive in the time for the reporting. This gauger is going to have to write down the measurements in his grease book. Later today, he'll call it into the office. Somebody's going to have to take in that information by phone in the office, put it on an Excel spreadsheet, or write it on a tablet, however they're handling it. It's also dangerous. The top 3 dangers to an oil field employee are, number 1, windshield time, driving. Automobile accidents account for most of the injuries and deaths for oil field workers. The second most, and the third, you're going to see in this video, second most dangerous thing is climbing the stairs. Here's a pumper going up an icy, snow-covered staircase. That's where a lot of injuries occur. When he gets to the top, you'll see the red flag. That's telling him there's toxic gas present, hydrogen sulfide. Remember when I turn your pics away? That's him talking. This is a video I found on the internet. That is a training video on how to measure a tank. That beeping sound is his hydrogen sulfide detector telling him to run for his life. Instead, he's continuing to measure. He's trying to turn it off because doggone it, he's doing a video. This happens all the time. You think it's kind of crazy. I certainly do. We don't go out there with our masks on. This happens all the time in the oil field. It's also increasingly regulated. Here's a special camera that sees the methane image of what it looks like, and this pumper's got his nose in it. You'll see him turn away for a second because it smells so bad. But this is increasingly regulated because of the danger and, of course, because of the environmental impact. In Colorado, a hatch, one of these thief hatches that they measure through, left open is a $10,000 fine for the first infraction. In New Mexico, all venting has to be reported now on a monthly basis. And there are lots of federal laws that are being cast around. There's one HR right now that requires 99% of all gases to be captured. Most of you are well aware of all that in this room. So SCADA comes with a huge capital expense and some significant operating expenses for installation of the equipment, maintenance of the equipment, transmission of the data, and then a way to view the data and interact with it at the office. The IT cost of that alone is a huge operating expense. We eliminate all that with this device, and we have one out in the hall there if you'd like to come see it. We offer this as a monthly service. We don't sell this equipment. We send it to the customer, they drop it on the tank. There's a 3-minute video that explains how to install it. It takes longer to watch the video than to actually do it. And the spool on the left is measuring oil level, water level underneath the oil, and a very accurate temperature of the average of all the oil. And the controller on the right there is self-contained, solar powered. It's got a battery backup, and it talks by satellite. So we don't need to send a technician out there to figure out which way to point the directional antenna to the Verizon cell tower. If this thing can see the sky, it can talk to the radio satellite. Here's what it looks like in general principle. The equipment is on the tank. The transmission goes over the satellite to our web portal. And the whole thing is included. We offer it with a free trial, with no long-term commitment. It's a month-to-month, go back to that slide. It's a month-to-month service. There's zero capital cost. A customer can cancel and just return the equipment anytime they want. And as long as they are paying for the service, it comes with a full warranty on the equipment. The real product, of course, is what's on that computer screen. What comes across the satellite, we can present on our web portal or send into an existing SCADA system back office IT or API. And almost more importantly, we can direct it to the person who's responsible for dealing with this information by text or by email. Most of our customers are using it most frequently with the text messages. The pumpers just love that. Here is a screen. I'll explain it. There's a lot of information on here. But all you need to know is that green is oil, blue is water. The green dots on the top are the satellite messages, and that white dot near the bottom is the load line out to the truck. So you can see, this was actually this past Christmas, December 25th last year. This is a customer's data where a particular tank on Christmas evening, 6:02 p.m., went into 80% full. The pumper got this message and actually went out there Christmas night. It went out not so much because it was 80% full, but because production had dropped. They expect about 12 barrels a day out of this well. It dropped to under 4. So we went out there. Sure enough, he cleared a valve, got production back going, and was able to start. We also called the truck Christmas night. They didn't get there till the next day. But so here's more information that I want to just kind of give you a quick idea of. Put yourself in the pumper's position for a minute. Your job today is going to be to go ride the fences on all these tanks, if these are what you're responsible for. And you've got to go up and measure each one before you even know what you need to do today. Well, with remote gauge, while you're having your coffee, oh, we got a leak right here. I'm going to go to that one right now. And on the way, I'm going to call a truck and sell this oil. I'm also going to make a call to get the water out of this tank. I've got enough oil to sell. It's in 80% full. So I better deal with it. On the way back, I'm going to go by and get the ticket and find out who rolled this tank. Some of you know what that means. That means they put the oil onto the truck. The pump probably went tone high, so they thought, oh, too much water, shoved it back in the tank. That's illegal, but it happens all the time. Once it's on the truck, it belongs to the hauler. Speaking of the hauler, we can solve 3 of their biggest problems, which are turn downs, which is that what happened with that last slide. We can eliminate the short loads. We can also help them gather split loads. I'm running out of time here, but we are finally ready to release this product. We've been in development for a long time because we had to invent our own system. We tried everything that's out there to get to this zero capital expense business model, and we finally had it ready to go. So if you're a producer and you'd like to know more about how we might be able to make this work for you, I've got a quick little assessment we can go through to see how we might be able to help you. If you'd like to know more about the company and how you'd like to join us in our endeavor to make oil production more productive, see us after. Thank you for your attention.
Awesome. Thank you so much.
A quick question and kind of thinking about how do you verify, like what's your testing to verify accuracy, and kind of how do you get confidence that the system is actually working better or than a SCADA system?
Well, to answer that, first of all, we are able to measure the location of the floats. We're measuring a magnet and its presence. We have resolution of 1/10 of an inch. And the system is either perfect or dead. So when it's dead, we go replace it. It's only happened a few times, but it does happen. The competition with SCADA is not really our focus, because our competition is every tank that is measured with a rock and a string, right? But we have, like that first slide, we do have companies that already have elaborate SCADA systems. They've already fully invested in the capital expense of that. and we can direct the data from our satellite straight to them. And we've been able to prove that our data is very, very accurate. We actually confirm it whenever we can with the pumper, because sometimes they won't drop it all the way to the bottom. We can see how much has been deployed of that spool, but we go ahead and compare it with their measurement. And everyone I've ever talked to has done, oh wow, that's exactly what I just measured it this morning. And so we've got a lot of anecdotal confirmation of that.
Okay, awesome. Thank you so much, Momus. All right, and now we'll have our final presenter this morning. We have Peter Photos with Streamline Innovations, and yes, I asked, that is his real name. Streamline Innovations is an environmental technology company realizing the vision of eliminating pollution through technology. So Peter, take it from here.
Thank you so much. So last presentation of the night, so most of you have conference fatigue, so I'm going to get started with something that's very, very exciting, and hopefully you will all get excited by what I'm about to say. I'm going to start with an equation. Aren't equations exciting? I think they are. MMSCFD, millions of scuffs a day, times ppm, divided by 12. Okay? Remember that, there's a test at the end. This is the amount of sulfur you're producing in pounds per day. And that equation works at a well, at a pad, at a gathering facility, even at a midstream facility. Millions of scuffs a day times ppm times 12. Now hopefully you will get that number to be 0. And not because the first thing is 0, not because you're not producing gas, but because if you're lucky your H2S is 0. But increasingly more and more, that number is getting bigger and bigger. The second thing, before I get to my next slide, because if you have a sour well, there's a variety of different things you can do to treat H2S. Right? You can flare, sour, you could not treat, you could treat with scavenger, you could build a clouds plant, you could build an AGI, all of these opportunities are there. And the old school rule of thumb, if you go back way when, if you have sour gas at a well, you treat with scavenger. And if you have sour gas at your centralized facility, you build an amine plant and send it to an AGI, or if you're outside of Texas, a clouds plant. I'm going to add some numbers to what I just said, because those guys are right somewhat. MMSCFD times ppm divided by 12. If that number is less than 500 pounds a day, scavenger might be your right solution. Scavenger is about $10 a pound, give or take, so that gives you an idea of what it's going to cost you. If you want to build an AGI or an amine plant with a clouds facility, you're talking, $15 million in capex, big numbers, and so therefore you could be way out of the park. You need to have that number greater than 40,000 pounds a day in order to make that economical. But there's a lot of places today that's changing because that number between 500 pounds and 40,000 pounds is growing. The number of sites there, that donut hole, where if I produce 1,000 pounds of sulfur a day, it's not cheap to use scavenger, and it's not enough to build an amine plant. And as the story's changing, right? Title V is getting tighter. People don't want to sell sour. People are mining Bitcoin at a site. You need to get rid of the H2S. You want to generate energy cogen at the site, or you want to start doing CCUS locally. You're going to have to get rid of that H2S locally. And you may very well find yourself in that donut hole between 500 pounds and 40,000. And so that's where we went back. Streamline is about 6 years old. We're a startup company like everybody else here. We started in Texas. I'm not a Texan, but we designed and built and did all the work here in Texas. And here we are presenting a technology that kind of fits right into that donut hole. And this is another way to look at it. This is H2S concentration in flow rate, and this is kind of the border between scavenger and a process called liquid redox. Liquid redox is a process that's about 50 years old, maybe a little bit older. Old Streckford unit, some of you know it as, sulfurox, LOCAT. And the cool thing about this technology is that it's agnostic to whatever the H2S is with. It behaves like a scavenger. You mix the gas with
the chemistry, and the H2S goes to zero. Just like a scavenger, except two major differences actually. One, we don't have sped scavenger, we actually produce elemental sulfur. So that makes it fertilizer, which is really cool and really green. But more importantly, you can take that used chemistry and you can add air to it. And adding air regenerates the chemistry. And so you can use it over and over and over again. So that gives you this economic advantage. You get the power of a scavenger and the economic advantage of an amine plant that regenerates. And so we've taken this liquid redox process, Streamline has taken liquid redox, and start over again. 1999, the US and European Union outlawed phosphates in dish detergents. A whole new class of chemicals to make your glassware squeaky clean came out. Streamline selected some of those chemicals to be used for the liquid redox process. Surfactants, we've mentioned some surfactants today. We've selected the right surfactants to make this process good. Because if you remember, liquid redox is prone to foaming and messiness and sticky sulfur. Well, that can be resolved with third generation surfactants and fourth generation surfactants. And then on top of that, process control. You're maintaining two chemical reactions in a very narrow band in order for liquid redox to work. This is a very difficult process to do. Even though we're getting rid of H2S, we're destroying H2S just like a scavenger, but we're maintaining chemical reactions. And we want to bring this to the oil field. We want to make this upstream rugged. We want Joe Pumper to be able to operate this. And so we have automated as much as we can. And we put an extensive SCADA system in. And I can show you my HMI because it's on my phone. I can operate my plants from the phone. And that's what makes this, so we've been able to take this technology, this old technology, give it a facelift, change the chemistry, change the process, and then change the business model. Because the big issue with why you don't want to build the Klaus plants is because it's a huge capital investment. So if we can eliminate the capital investment for one of these plants by making a leasing model, so it's $0 down, and you pay by the pound just like you pay with scavenger, you get the best of all the worlds. You get the effectiveness of the scavenger, you get the cost efficiency of liquid redox. You're making salt, you're turning your H2S into fertilizer, which, hey, that's pretty green. And it makes sense business-wise. So here's the process. I'll give you a quick rundown in 30 seconds or less. The first section is just like an ultrafab. Gas comes in, it mixes with the talon, it comes out sweet. That's it. Behaves just like a scavenger. You could think of it that way. Except, as I said, the two differences. One, we could take the chemistry and send it back around, mix it with air, and regenerate it. So our makeup rate is very small. So 1 gallon of scavenger kills about 1 pound of sulfur. 1 gallon of our chemistry can kill about 55 pounds of sulfur. And our latest iteration, 155. And then finally we have to remove the sulfur. We take the sulfur out of the bottom, send it to a filter press, and come out to the top and go back into the system. This system can be adapted to a variety of different environments because it's agnostic to what your H2S contains. So it can contain H2S in natural gas, H2S in CO2, H2S in air, H2S in water, H2S in nitrogen if you're coming out of a Klaus plant. So we can take this process and modify it to fit a variety of different needs. And so in only 6 years, using this chemistry and these changes that we've made, we've actually developed a whole library of technologies that we can use across the oil field. By the way, this is what the sulfur looks like. It's a bright yellow cake. It goes into a dumpster, into a roll-off box. That's our chemistry. It's called talon. And every time, straight to zero. Very, very good stuff. It works just like a scavenger in the sense that it gets you to zero in a very fast amount of time. And so we've created a variety of different technologies across the library here. You know, our Valkyrie skid is designed to be a single package. We drop it off at your site, we drop it off at a site, and it treats a half ton, 1 ton. It's pre-designed. If it fits your needs, it fits your needs. If it doesn't, too bad. If you need something more sophisticated and bigger, it can be done so. We can build huge plants. That's a 20,000 pound a day facility. That's a 500 pound a day facility. This treats CO2 and H2S. This is actually an amine plant
with a Super Valkyrie behind it. So now, instead of going to an AGI or a Klaus plant, you can go to us. The Ultra is the super small package, 500 pounds. If you want to do water treatment, produced water, industrial water, we do that too. Air, over there on the right, is for like vents for facilities, headworks facilities. And then the last one, too, worth mentioning, that eco, is biogas. Because I mentioned that donut between 500 pounds and 2,000 pounds, 20,000 pounds. Well, landfills all fit into that. Biogas digesters fit into it. Biorefineries fit into that donut. And they all have H2S, and they don't really have an economic solution. So these are designed for biodigesters and even 250-pound units. These are going to compete against your high-end scavengers because we get the capex down to so low that you could rent this for cheaper than it does for an ultrafab. So we don't have a lot of time, so I want to kind of get to the summary of this. You know, the old way is to flare or to treat cell sour or to add scavenger. Keep in mind, scavenger is toxic. It smells. You don't even know the smell of scavenger, but it stinks. And when it's spent, it's even worse. And it's flammable, and it's hazardous, and it's awful. Other treating methods don't really work economically at that mid-size scale, between 500 and 20,000. And so H2S really has to get sent to something nasty that can kill things. Streamline has developed our plants to convert H2S to water vapor and elemental sulfur, which, by the way, is certified for organic farming. So not only we take something bad, we turn it into something good. So as I like to say, not only because we're cheaper, we're more efficient, we're also greener. We appeal, I don't know if this will go over in this room, to both Republicans and Democrats alike. We save money and we make the world greener. Like I said, I don't know how much that joke is over in this room. But to come back to my point, there's a variety of different ways that you can do something with a sour gas well. And, you know, treat, not treat, there's a whole different route you can go. And really, if you start looking at where we can fit into the story, we could treat at the wellhead. We could put our units out at, let's say, an exceptionally sour wellhead. Or, centralized treating, we could build a 20,000-pound plant. That means you don't have to build a Klaus plant or an AGI. Or you don't have to find sour takeaway because there is no sour takeaway in that region. And by the way, sour takeaway is becoming more and more hard to find. So there's a lot of different places we can fit into the story. And so with that, I'm going to leave it back to you guys because they wanted me to earn back about 5 minutes of time. So
we appreciate that.
I told you I'd cut it short.
You're amazing. Thank you.
Thank you.
David, do you have any questions?
On commercial traction, you mentioned a few different size units. Can you talk a little bit about how many of those have been installed of each type, how much churn you've kind of had?
Sure.
And kind of what the pipeline looks like going forward.
Great question. We're doing well. We're doing really well. We have about 27 units in operation right now. That's in the past 6 years. We have about 25 of these, about 2 of these, 3 of these, 2 of those, and then a variety of wastewater industries up and down the East Coast. So we have about 6 more in fabrication, and we're hoping to be at 45 units by mid next year. We've come a long way.
And all 27 of those are at their original installation location? They're kind of designed for...
Actually, good story. Good question, because these things are very mobile. Again, he's being my Confederate here. These things are very mobile, right? So they can be installed in about 3 days. It's a bunch of skids. So we had a client that put this on their well. Their well declined. This is a 2,000-pound unit. The well declined. It got to about 500 pounds. They had kind of passing the economic threshold. So they picked it up and moved it across the street in a week. Now it's treating 2,000 pounds again. And then they move it down the street when that's done. So that is actually a great story, is that because they're so mobile and they're so easy, they just get moved around.
And then do you own the sulfur and provide for the logistics and sell the fertilizer? What's that part of the value chain look like?
This is actually another interesting question, because sulfur, if any of you look at your production contracts, older than 30 years old, sulfur is actually listed as a mineral. And so technically it's owned by the landowner. However, The second thing to know about sulfur business is it's very much like the bottled water business. The water is not the expensive part, it's the transportation and shipping and everything. So once you explain that, you say, look, there's no money in sulfur, we just want to get rid of it and give it to farmers, or we are just going to send it to a landfill, and the landfill will give us a discount because they could use it to offset some of their uses. The producer's usually okay with it. So that value chain, don't hang your hat on the money on that. The money is in, selling chemistry. Anything else?
Okay, thank you so much, Peter.
Thank you.
All right, so now we'll let the judges talk so that they can determine who their pick for most innovative will be. And we'll now hand it over to you so that we can do our audience favorite award. So if you look here, you're going to text your favorite code. So they're in order of who presented today. And so you'll text that number, like 160 and then whatever the following is, to the number 22333. So again, you'll get out your phone, you're gonna text like you're texting someone, like your BFF, 22333, and then Haley's gonna pull up the live poll, and you can see the code again. So we'll hang on a moment while we're doing that. So many great innovations today. So thank you all the presenters for being here. Let's give them another round of applause while we're pulling that up. What I can do as well is we'll have another energy elevated presentation at our Lone Star Energy Forum, which will be November 15th through 16th in Houston at the Woodlands Resort. So we'll have a page up soon that have a QR code. You can get more information on the TXOGA website. So again, yeah, you're gonna text, like you're typing in someone's name, 22333, and then you'll text one of those numbers of who you think is your favorite technology that you saw today. I'll give everyone another minute. I know the suspense is here. And I'll grab the award as well. Have their votes in. Haley, are you going to pull up the live? Okay, Todd just reminded me that May 16th begins early voting for our runoff elections here in Texas. So mark your calendars. I know we just had an election for those constitutional amendments. We got to get you back to the polls for those runoffs. So make sure you check the Secretary of State's website for more information. I know the suspense is killing us here. Technology, technical problems, so they all go hand in hand, right? I will say, after we present the awards, we will have a networking opportunity for y'all to talk to the presenters, to the judges. You can go visit the booths that are out there. Okay, here we go. Okay, it looks like Protonic Tech has won. So Protonic Tech coming up. Let's give a big round of applause. Awesome, here you go.
Thank you for hosting.
Absolutely. Congratulations. Audience favorite. One more hand for them. All right, now, judges, you'll want to come up here. You can bring your mics and we can give out your award.
Happy to. First things first, Dale and I put our heads together. Really, I think we ought to give everybody a round of applause for all 8 going. Really, it's not a simple solution. And we went through, and it's actually a testament to the fact that the energy business really is a tech business, and everything that happens downhole happens a lot, but now everything that's happening on the surface as well. So really kudos to everybody. So thanks for having us.
Awesome, thank you so much, David. And Robert, here you go. Awesome, congratulations. Thanks. Okay, and now for you in the audience, it's your time for your prize. So we have this wonderful Yeti cooler here. Oh, are they withdrawing from inside? Oh, this is very exciting. All right, so pull out your little raffle ticket. Okay. It's why you don't have one, correct? Okay, just kidding. 106881. 881. Yeah? Okay. One more time. 106881. Okay. Todd wants you a minute to check. All right, well, deal with it. Thanks, everyone. Okay, so you can see more information for our Lone Star Energy Forum. We'll do another energy elevated technology showcase. Go out and talk to folks right now, and then we'll pull everyone back in for lunch in about 15 minutes. So thanks, everyone. Appreciate it.
continue to chart a course for a bright future, for a more sustainable and affordable and reliable energy as we move forward to meet the growing world's energy needs. You know, when you think about Texas, we're certainly a leader. Do you agree? I mean, Texas, we're kind of proud of Texas, aren't we? We kind of like that. That's a good thing. We are a leader, I believe, for about three basic reasons. We have population, we have resources, and we have policies that enable all that to come together. Resource development is key to our future growth. And that's what this Energy Elevated Technology Showcase is really all about. How to develop those resources in a way where we can meet the needs of a growing world. The oil and gas industry certainly is going to have a phenomenal role to play. Obviously, not all policymakers understand that today. We know that innovative solutions are going to change our world to some degree, but it's not going to change it overnight. And so, looking at ways to be more efficient, to be more effective, is what this industry is leading on. In fact, in 2017, several of the world's largest oil and natural gas companies invested $6.3 billion in low emissions technology and research to address climate concerns. Our energy companies are leading the way to climate progress, and that's what's occurring. Now, I know today we have many different professional backgrounds in the room. I suspect we have a few engineers here today. Anybody, a few engineers? I see. We have any finance people out here today? Got a few, any attorneys here today? Thank you. You can leave now. I'm not kidding. How many communications people do we have here today? A few hands. If we're not all in the communications business, we're in trouble. We have a very powerful story to tell, and it's one about growing our world, having a better lifestyle, living better, living longer. And innovation and technology has been the genius of American success in terms of being a leader in the world. And the question is, for us here today in 2022, what kind of legacy are we going to leave to that next generation? Are we going to allow the United States to continue to meet the needs that we have here at home for our citizens and for our allies around the globe? That's very serious questions for those people around the world today that are suffering mightily because of decisions that they've made that have been compounded by the aggression that we've seen that Russia is taking place and the uncertainty that it's creating. I'm glad that we are focused on ways to look forward, ways to work together. One of our speakers talked about Republicans and Democrats. We have independents. We have moodocrats. It's whatever mood people are in today, you know, is what their policy choices they're going to make. But one thing that we should be able to come together on is really research, development, innovation, and technology. And I hope we leave here today more informed, better equipped to tell that story about communications of what this industry is doing. I'm really excited today to cap off with our lunch and keynote speaker, Dale Winger, the Managing Director of Halliburton Labs. Dale, we're excited for what you're going to bring. Halliburton Labs is a collaborative approach, bringing in technologies, making them commercially viable. It's exciting what you all do. We thank you for being here with us today. Let's give Dale a round of welcome here.
Well, good afternoon, and really thank you for the nice introduction, Todd, and just want to express my gratitude to the entire TXOGA staff for putting on a really great event. Neil, Jamie, Shayna, everybody that was working together to make this happen. I learned some things this morning and learned about some new tech and had some great conversations with some good folks. So Really appreciate everybody being here and engaging in discussions on energy tech. It's certainly really important to what we do at Halliburton Labs, which I'll tell you a little bit about in my role there as a managing director. But before I get started, can we give one more round of applause to the entrepreneurs for today's pitches? Look, there's a lot of business people in this room that know what the hard work of entrepreneurship looks like. And so for these folks to kind of take that risk, start a company, ride the ups and downs of that journey, at the same time trying to develop and scale technology, trying to prospect for potential clients, managing cash, fundraising, and seeking strategic partners. It's a big job, and we really admire the founders and the leadership teams that embark on that journey and actually contribute a lot of innovation and ideas to the industry. So I'm going to tell you about Halliburton Labs today, which was an approach we started just a little over a year ago, about a year and a half ago. Now, I don't think Halliburton needs a lot of introduction in this forum, but for those that don't know, our core business, we're a 103-year-old oil field services firm, $15 billion in annual revenue across 70 countries. Yet almost all of the business today comes across the traditional oil and gas value chain, from exploration and drilling type services to completion and production type services. And so, of course, we firmly believe that oil and gas are going to be very important, affordable, and reliable resources for decades to come in the energy system of the future. But at the same time, we recognize there is going to be a lot of innovation. There's going to be importance around decarbonization, cleaner sources, and there'll be business opportunities to engage with those. And so Halliburton Labs really reflects our commitment to the science and continued evolution of sustainable and reliable energy. So we know, what we do know is that the energy system of the future is going to look different than the one that we have today. And there are going to be new corners and new technologies in that energy system that are beyond what we would think of as Halliburton's traditional perimeter in terms of the places that we engage in the value chain and the types of services that we provide. And as you probably saw from this morning's pitch event, there's going to be a lot of technology that gets developed and brought to the marketplace that's developed outside of the incumbent energy firms. Yet, these startups, these companies that maybe aren't an incumbent energy firm today, are going to have a lot of need for scaling resources to help, identify pilots, design for manufacturing and reliability, commercialize, and go to market. And so we've set Halliburton Labs up really to be a front door to connect these early stage companies with the resources that are available in the incumbent energy system. Now, innovative early stage companies have a long capital intensive journey ahead of them with numerous engineering and scale up risk. And what we're talking about here is if we're going to bring forward new energy technologies, it's not going to be a ones and zeros exercise. This can't just be software and cloud-based solutions. There's going to be a need for significant scaling of chemistry, of materials, of equipment, of other hardware that just has a time and risk profile that's very different than software and digital businesses. And when you're an early stage company, a misstep or two that costs critical time or money can be the difference between successful commercialization and a company that's propelled on a really positive trajectory and failure. I mean, companies go out of business because they run out of money. And they often run out of money because they run out of time. And so we at Halliburton Labs help early stage companies use their time and money, their capital, as efficiently as possible, leveraging capabilities that we've developed from 100 years of participating in the energy system, and also lessons learned from our own experiences with commercialization. So we're primarily using our existing invested capital, and that's one thing that's pretty distinct about this model. It's not a traditional corporate venture capital type model where we see this as primarily a financial investment and we're writing checks and looking for returns. Really, it's more of a strategic exercise where we are providing access to facilities and to people and to our business network as an opportunity for early stage companies to use their resources more effectively, and for us to create new relationships with people and technologies and markets that might not otherwise come to Halliburton. It's an open and collaborative environment, and so what that means is we're focused on the success of the entrepreneur, and the ecosystem is more valuable to the entrepreneur and to everyone the more people that are participating in it. So if a company joins Halliburton Labs, they have no restrictions at all in terms of who they can sell to, who they can raise money from, even if it's a Halliburton customer, or a Halliburton supplier, even a Halliburton competitor. So what we've tried to do is in the spirit of making things founder-friendly, is to reduce a lot of the frictions that oftentimes prevent big companies and small companies from working together very effectively. And there was a mention of one or two of those things from this podium this morning. And so what that means is when a company comes to be a part of Halliburton Labs, we don't take board seats, we don't require any rights of first refusal. All the IP that the company develops while they're participating in the accelerator program belongs to the company. And so, as I mentioned, this gives us insight and understanding to important technologies that could be meaningful in the future of the energy system, and also help us inform our own strategic decisions as a corporation as the transition unfolds without committing significant capital. So rather than trying to speculate in 2022 on what the winning technologies are going to be, our approach is to help create more winning technologies. So what is the program that we're talking about here? So it's an industrial clean energy accelerator program for early stage companies. So as we've discussed, the energy system of the future has to be affordable, reliable, and cleaner, okay? And so as this group knows, we can't just solve for one of those. We've got to solve for all three at the same time. And the picture on the slide gives an example of some of the spaces that are available. So the picture on the left is 6,000 square feet of wet lab space in our Global Technology Center. We have in Houston, we have significant analytical capabilities on the floor right below that. The space on the picture on the right is makerspace. So this is also on our corporate headquarters campus. This actually used to be a drilling tool assembly shop. And during one of the last downturns, we consolidated some of those operations into a single location, made this building available. But this is an ideal space that's already kitted out with crane. We have an accelerator participant, a company that's in Halliburton Labs, that has achieved a 50x scale up of their manufacturing process, which has allowed them to manufacture a novel insulation and fireproofing material, and these additional quantities have allowed them to supply sample quantities to a number of Fortune 500 companies. And Halliburton's role in that, in addition to providing the space, is to develop standard operating procedures, industrial health and safety, to allow the company to participate, to accelerate their path to participate in those opportunities. And then beyond that space on the right is a large paved laydown yard, and shipping and receiving and 24/7 security for the companies to access. And so how does a company become part of Halliburton Labs? So we have an open application process. So on our website, any day of the year, there's an orange box that says apply now. What we are looking for is for companies to have progressed their technology at least to or beyond proof of concept. So what we're not is like a university or a government lab where we're doing research or doing experiments or trying to get the science sorted out. We're really looking for companies that have settled their science, and maybe they've made 1 unit or they can make 1 kilogram, and what our role is to help scale that up. We're very good at scaling up the engineering scale-up process and sort of thinking through all of the implications of how to do that cheaply and reliably. And typically we're looking for companies, either they've had one round of institutional financing or they've got a round upcoming maybe in the next 6 to 12 months to secure institutional financing. So a lot of the companies that come into Halliburton Labs are self-funded or have received some government grants, maybe have some angel investors or some friends and family money. So that's how a company applies, and so we do 3 finalist pitch events every year. We do one in January, one in May, and one in September. And so we'll get several dozen applications for each of those events, and from among those applications, similar to the format we had here today, we select down to typically 8 to 10 finalists, which we'll pitch to our advisory board, and then we'll often select 3 or 4 of those to join for a 1-year experience that I'll tell you a bit more about here in just a second. Now, I do want to put in a plug. These pitch events, in the spirit of being open and collaborative, these are public events that include hundreds of registrants globally from around Halliburton's extended network. So it's actually a great day of visibility for the companies that participate in it. There's a lot of connections that get made in terms of whether it's early stage venture capital investors or corporates or corporate venture capital, identifying companies or seeing them for the first time at a Halliburton Labs pitch event where they previously hadn't been on the radar. And if you would like to attend, the next one is Friday, May the 20th. We have in-person and virtual participation options. The in-person option will be in Houston. But there's a link on our website, halliburtonlabs.com, and so if you want to just come see what it's about and what kinds of companies are coming, we would love to have you there. So I mentioned that the advisory board plays a role in the selection of the companies, and we're really proud of this group. They've been super helpful in terms of guiding the company selection and being open-minded about all the different possibilities of technologies that might be important in the future. As you can see, we have 3 CEOs on our advisory board. One of those is Halliburton CEO Jeff Miller, who has provided a lot of executive sponsorship for what we're doing, and a lot of the support that Halliburton Labs provides to the companies is not really provided by Halliburton Labs staff. It's really Halliburton Labs connecting to experts in our organization. And so sometimes companies have, manufacturing questions and looking for, to develop some options. And so they get connected directly in with a manufacturing director who has a full-time day job to manage a budget and build a team and hit quality and safety targets. And so that's one of the things that's pretty unique about the model. A couple other CEOs, very proud to have Jennifer Holmgren, the CEO of LanzaTech. They announced earlier this year they're going public in a $2 billion SPAC transaction. And Maynard Holt, the CEO of an energy information platform that he started earlier this year called Veriton. Many in the room will be familiar with Maynard from his days at Tudor, Pickering, and Holt. Reggie DeRoche is the incoming president at Rice University. John Gratzinger's former chief scientist on Mars rover missions. And then, of course, Walter Isaacson, very distinguished author, wrote the book on Steve Jobs and Leonardo da Vinci. He actually leads off each of our finalist day sessions with a keynote discussion. In some recent discussions, we hosted Ira Ehrenpreis. Ira was an early investor in Tesla and actually a current board member at Tesla. And Carmichael Roberts. Carmichael Roberts is the investment committee lead at Bill Gates' Breakthrough Energy Ventures. And so really our goal with the keynote is to sort of build this bridge between energy entrepreneurs that may be outside of the incumbent energy system and the incumbents. So what does it mean to be a Halliburton Labs participant company? So after the winning finalists are selected, our participants really have 2 important tracks, kind of the light blue in the middle and then the dark blue at the bottom. And I won't take you through every box of the ways that we engage with the companies and the types of support that we provide. But the big picture, there's a structured curriculum track that the companies participate in together. And so this actually happens weekly where the companies come together to focus on a topic that's led by an expert. So we double click down on something that is either important to the business right now or it's going to be important in the future as the business scales. And so you can see some of the topics that are listed in the light blue boxes there, but it's everything from developing and executing an intellectual property strategy. We talk about fundraising and equity management. We talk about the strategy of the business and really getting super clear on product market fit and sources of competitive advantage. We talk about how to build a great board. Sometimes companies get to a stage and realize they don't like the way the board got put together, and so sort of thinking about that from the beginning is really important. And then a bunch of things that Halliburton just has decades of experience in: supply chain, manufacturing, industrial health and safety. As you know, to scale a business, to participate in the global energy system requires being very, very good at those things. And so that's kind of the curriculum track. A lot of times that identifies opportunities and creates discussions and gets founders maybe thinking about some things that they weren't thinking about, or identifying resources that can help inform what they're doing. And that really sort of creates sort of this transition to the second lane in the dark blue at the bottom. And we think this is where the real value of the program comes from, and that's our company-specific priorities. And so what we'll do at every company that joins Halliburton Lab, we'll typically spend around a day with at least the founder and a lot of times a few leadership team members, maybe CTO, COO, and we'll talk about what are the short-term and medium-term milestones. And that can really be anything that's keeping them awake at night, or any rate limiting factor that needs to be addressed for the business to pick up more clients and the business to pick up more investors. And so by having that conversation, they begin to get a really clear sense of what kind of capabilities we have and what kind of resources we can connect them with. And at the same time, we learn a lot about what's important to the company, and what opportunities are kind of at the top of the list that can create value with successful resolution. And to us, that's what the acceleration process is all about, is helping the company achieve the commercial milestones that help them attract more clients, demonstrate their technology at a larger scale. And when those things are done, the pool of prospective investors and fund companies that are doing those things, that are on schedule, getting things done, gets a lot bigger. So I'll give you a sense. One of the sort of ways that we think about like what types of companies to have in Halliburton Labs, because our goal is acquiring access and relationships with new people and new markets and new technologies that might not have otherwise come to Halliburton, we are typically looking beyond the perimeter of something that would fit obviously into an existing service line that we have. So Halliburton still has a technology organization and a scouting department that is looking for technologies to sort of incorporate, into one of our existing, tools or services type businesses. Really, the value add of Halliburton Labs is to expand that perimeter into technologies that probably wouldn't have come to Halliburton otherwise. And so, without taking you through all 15, I do want to highlight the geographic and technical diversity of the companies. One of in the founder-centric, model, we don't require that companies have to use our physical space or move to Houston, Texas to be able to participate in the program. A lot of the value that they get is getting connected with us and getting connected with our business network. And in a post-COVID world, a lot of people are comfortable with frequent relationships that are conducted on Zoom and telephone. And so, we do have a couple of Houston-based companies, but we have a Canadian company that's doing surgical mining by drilling. We have a California company working on industrial energy storage. I mentioned earlier a Texas company that's making novel insulation ingredients, sort of addressing the conservation side of the energy equation, and a European company that's building drone infrastructure. So just to give you an example of like what an engagement might look like, I'll introduce Nexor Bioenergy. They're on the bottom row there. We've got Momentum Technologies, who's recycling lithium-ion batteries. Next to them, we have Nexor Bioenergy. They manufacture an on-site renewable energy solution. So it's a container-sized unit that can convert any organic, plastic, or biomass waste into renewable power and thermal energy. They're receiving a lot of demand globally, ranging from developing markets to developed economies. And our broad global network in terms of how to build and scale a global supply chain has been very helpful in terms of Nexor achieving its scaling plans, and also make a pretty important impact to address waste and create a behind-the-meter source of power. So happy to discuss any of those companies with you if you have more interest, and they're also listed on our website. So in the spirit of open and collaborative, it's our deal flow is out there. You can see who's coming at the finalist day, and you can see who's in from our press releases on our website. So last slide here, I just kind of wanted to highlight, like, what does success look like for us? I mean, if we're doing a good job of helping companies scale and achieve commercial milestones and become more investable, then they should get invested in. And so we've had 4 companies now that have completed the 1-year experience. And that 1-year experience really includes almost unlimited access to Halliburton people, and if we can be helpful with it, with any of our 40,000 people in 70 countries, we will. And so one measure of success is, are the businesses getting funded? And so of the first 4 participants that have joined and completed their 1-year experience, 3 of those did raise their first round of institutional financing during their 1-year experience at Halliburton Labs. Those 3 companies raised a cumulative $35 million, which is a pretty good number for Series A round of financing. We've completed 4 finalist day pitch events and included about 40 finalists from around the world, working across all different parts of the energy value chain. So really, while we're not really looking for things that fit into an existing service line, we are looking for some sort of connection to energy or industrial decarbonization. But that really can cover, I mentioned the conservation case earlier. That can be the number of enablers that are going to be required to increase the amount of renewable power that's on the grid. Storage technologies are obviously an important part of that equation. So anything from how we make it to how we use it and transport it and distribute it and store it are kind of in scope. We do have an equity for services model, and so what we are, as I mentioned earlier, what we're not really is a typical corporate venture capital check writer, as much as we are looking, when these companies get to a round of institutional financing, that Halliburton Labs then joins the cap table on the same terms as the lead investor with a small single-digit percentage of equity. And so we're really proud of the early results of companies achieving the scaling milestones that have made them more investable on hundreds of millions of dollars of valuation. So I appreciate the opportunity to be with you today. Really welcome your questions. Like I said, because it's an open environment, it's more valuable to everybody, the more people that are participating in it. So if you have interest in being a part of some of the events or getting connected with some of the companies, we're certainly a conduit that could do it. And from our standpoint, it's been really helpful strategically for the company as a way to build network and understanding and relationships and trust, really solid business relationships with a bunch of bright, talented folks that are going on that founder's entrepreneurial journey to commercialize technology and make an impact on an energy system of the future that is affordable, reliable, and clean. So I think we've got some time for questions.
Let's give Dale a round of applause, first of all. And we do have time for Q&A. There's a couple of ways to do it. There's a pad on your table. If you want to write down a question, hold it up. One of our staff will grab that. If you just want to ask it, as long as you don't filibuster a question, we'll give you a microphone to do that. Before we start taking questions real quickly, I think State Representative Brooks Landgraf made it in with us today. Chairman Landgraf, stand up. Let's recognize you. Thank you for your service. We appreciate it very much. Thank you. And I see TCEQ Commissioner Bobby Kanika. You got introduced earlier, but you're out of the room, so let's give you a round of applause, too. Thank you. Okay, I'll let you take questions.
Are you still accepting applications for the writing?
No, so the cutoff day is typically around 3 to 4 weeks ahead of the event. So the deadline for the finalists have been selected for May 20th. They'll be announced probably in the next week or so. The cutoff deadline was somewhere April 22nd or something like that. It might have been April 26th. And then the next pitch event is September 28th. And so one of the nice things about having it, you've never missed an opportunity for very long. And so there'll probably be like a late August application deadline for consideration for September. But you can apply, if there's interest, you can apply anytime. I mean, it's kind of a rolling open application window. We just kind of cut it off in terms of when we select each crop of finalists.
Of that $75 million of three companies, is Halliburton one of them, the investment one?
No, so that's actually a really important part of the model. What we tell companies that we're not going to be the financial investor. We're creating an ecosystem where we will provide access to scaling resources that will de-risk that investment for a potential financial investor. But we actually think it's quite complementary and validating to have financial investors in the ecosystem. So if we're doing the scaling and writing the checks, sometimes we might just really like the taste of our own cooking, but when we're helping with the scaling and then a financial investor who is a professional at evaluating early stage venture makes that investment, it's quite validating that what the company's up to is worthwhile.
So Halliburton is not taking any equity position?
The equity position comes from services that we provide, so there's a single-digit percentage of equity that if and when the company makes it to a round of institutional financing, Halliburton joins the cap table in exchange for the services that are provided. So it's the actual instrument is typically a safe note, a simple agreement for future equity. So when the companies get selected, part of the participation agreement that kind of explains the relationship includes that safe note that allows Halliburton to come onto the cap table in exchange for the services provided.
I have a question. So one of the challenges with incubators is there's a sweet spot of maturity of the company, right? So if I have an idea on the back of a napkin, I can't start a company with that. And then 6 months to a year, some magic happens, and then suddenly I'm too big for my britches, and I'm not really eligible for something like this. So the question is where is your sweet spot in terms of progression along the company from an idea to, between the idea and the reality, between the motion and the act falls the shadow, as T.S. Eliot said. So where along that line is your sweet spot for your incubator?
Yeah, so the proof of if you are a fan of like technology readiness levels, which we are as an organization, we're typically looking for the company to have achieved TRL4, which means that the concept has been proven out, whether maybe it's just a kilogram or a liter or a laptop, kind of a benchtop version of whatever the company is working on. But it's beyond an engineering design. So there is something that can be scaled. Of course, we do diligence on, we do technical diligence just in terms of like make sure we're not, violating a law of physics or thermodynamics or something like that. Like make sure that the science that's been settled actually makes sense and could be promising at a larger scale. And we do feel like what the area that we're playing in a company's life is actually probably an underserved part of the market overall. I mean, there's lots. There's more resources available, kind of early stage. This is kind of a unique set of resources that are available for a company that's now ready to go start serving industrial clients and really start going from being able to make one widget to fulfilling an LOI to deliver 150 widgets over the next few months. And so that's kind of the sweet spot where we think what we're good at and some of the experience and capabilities we have can help. And like I said, we don't view any of the other incubators or accelerators as competitors. We actually, a number of the companies that are in Halliburton Labs are also affiliated with, Greentown Labs is one, Capital Factory is another. There's actually a lot of good resources out there. And so, we see all that as incrementally additive, but also think we're probably contributing something that's a bit unique that you may not find in some of the others, just because the people that are doing, our mentorship are, people that have kind of full-time professional day jobs working, in those functions or in those geographies.
So, Dale, could you define institutional investor? Is that private equity? Is it other institutions or extremely wealthy individuals, household names? What do you? I think this is a two-part question. So first part is define institution.
Yeah, so beyond friends and family money and angel financing, and so it would be dilutive equity that's provided by an institutional investor. So typically, that's a venture capital firm. It could also be private equity. It could be a strategic. It could be a corporate venture capital that's making an early round investment.
Okay. The second part of the question is you talk about Series A. That tells me it's more C Corp. Do you deal with companies that are LLCs, S Corps, or C Corps? Do you have a sweet spot?
We C Corp is best. So we have admitted companies that have LLC structure, and we have to design a different set of documents for that. Most of I would say over 90% of the companies are C Corp.
Thank you.
One more. Let's give Dale a round of applause. Thanks so much, Dale. We appreciate your leadership, Halliburton Labs, Halliburton's leadership in this industry. We thank all of you for participating today. We believe that this story is very important to the future of our state, of our nation, and we thank all of our presenters for making it possible and for those of you that attended. If this is your first Texas Oil and Gas Association event, I hope it's not your last. There are a couple of ways that you can stay in touch. Certainly our website, TXOGA.org, is a way to do that. But also you can take your cell phone out and text me at the number on the screen, 52886. Put the word TXOGA in there, and it'll give you an opportunity to get information about events, topical issues. I promise you we won't blow you up because I've done that myself, and it's a good source of information. So text me at 52886, the word TXOGA, and we'll want to keep you informed. We have some exhibitors out in the hallway that set up booths today. I hope you will show them the courtesy of stopping by. They provide a great deal of good information, and so please take a moment to touch base with them. We have had several inquiries about how you might get contact information for the presenters today. We're going to work with them, and we hope to let the attendees know the contact information. We'll certainly get their approval and the right process to do that. We also, this has been live streamed today. This should be available on our YouTube channel here in a few days. So those are a couple of ways that you can stay in tune. Anything else? That's got it. Thank you all for being here today. We are adjourned. We appreciate your involvement.